Hello friends, good morning, good afternoon and good evening to everyone watching this video. So today we are going to start with a new chapter today we are going to start with a new topic, permutation and combination. So most students think PNC, permutation and combination, we are going to use short form of this which is known as PNC. So yeah, most students think PNC is difficult, it's not. The real problem is they try to memorize formulas without understanding the basic logic. Today, I'll break PNC from the absolute foundation. If you understand today's video, every future topic becomes easy. So yeah, this is the base video for permutation and combination. So today we are going to learn about, first we'll talk about introduction to PNC. Then we'll learn about meaning of counting in PNC. Then fundamental principle of counting, which is also known as FPC. Then we're going to take some examples of FPC. Then there's introduction to factorials. We'll learn about factorials in this video. Then we're going to see some applications of factorials, and then we'll solve some basic permutation like problems with no repetition. I'll talk about what is this repetition, not no repetition, and then we'll get a small summary of the concepts we've learned today, and then we'll solve some practice questions. So yeah, this is the index for today's video. So yeah, let's start with our video. So introduction to PNC. So when we say PNC, we are talking about counting possibilities, not counting like 1 2 3, but yeah, I mean counting how many ways something can happen. Now for example, let's take, if we have two shirts and we have three pants. So how many outfits can I make? Simple, we'll just multiply 2 by 3, that's 6 ways. So we know that there are 6 ways, 6 outfits that I can make from 2 shirts and 3 pants without repeating any of them. So what is this? This is PNC in real life. So this shows that we are not just counting 1 2 3, but we are actually counting the number of possibilities of wearing different outfits without repeating each of them. Now if we talk about it in detail, the same 2 shirts with 3 pants. Now let's take this, a black shirt. Let's take this for example, and then there's a red shirt. Now for pants, let's take there's a black pant, a red pant and a green pant. Yeah, it's a very weird combination of pants, but yeah, let's just take this for example. Now how many outfits can I make without repeating? Now first we can take a black shirt and a black pant, which gives 1. Then we can take black shirt, red pant, which is a second outfit. Then we can take black and green, which is third, and then same goes for this 4, red shirt, red pant, which is fifth. And then let's take this here, this is 6. So we can see there are 6 possibilities. We can 6 possibilities of outfits we can make without repeating, and we did the same way by just multiplying the 2 shirts and 3 pants. So yeah, this is PNC in real life. Now we'll learn about the fundamental principle of counting. So yeah, let's move on. Alright, now we'll learn the most important rule of this entire chapter, that is the fundamental principle of counting. So this principle says if one task can be done in m ways, we'll take the same example of 2 shirts. So if example there's one task of selecting a shirt, then there are 2 ways. Here we'll take m ways, but yeah, just know that m is equal to 2. So there's m ways of finding one shirt, and then there's and another independent task can be done in n ways. For example, pants. Now selecting pants is independent of shirts. There's no condition that if I have a black shirt, then I cannot use a black pant. I can wear black shirt and black pant. So there's n ways of selecting pants, which is where n is equal to 3 because we have 3 options, and for shirts there are 2 options. So yeah, then both tasks together can be done in m into n ways. Both tasks here can be done into m into n ways. We have seen the example before only that we had 2 shirts and 3 pants. Then when we multiplied 2 by 3, we got 6. And by actually seeing how many possibilities we can, actually counting the number of possibilities, we also got 6. So yeah, this is the fundamental principle of counting. Now let's take another simple example. Now I have shirts. I have 5 shirts. So 5 shirts. Then the number of ways in which I can select one shirt is 5 because there are 5 shirts and I can select one each time. Then there's 10 pants. I have 10 pants. Then the number of ways in which I can select a pant is 10 because I have 10 options, right? Now how many total outfits can I build, can I make from these shirt and pants without repeating each other? Then simply we'll multiply 5 into 10, which is equal to 50. Then I can make 50 outfits from 5 shirts and 10 pants. So yeah, this is another example of FPC. This sounds simple, but trust me, 90% of PNC questions come from this idea. Of course, not this simple. It would be little complicated, yeah, but this is the base of PNC. Also, before moving on, note that both the tasks should be independent of each other. Like selecting shirts and pants was an easy example where we can see that selecting a shirt is independent of selecting pants and selecting a pant is independent of shirts. This only works for independent tasks. Now if we have some dependent tasks, like I have a black shirt. If I select the black shirt, then I cannot select the black pant. Then we cannot just use this principle because there would be some conditions to apply before using this principle. We'll talk about this later, but now for till now we need to just remember that it does not work. Whatever we learned does not work for dependent tasks. Alright, so now let's move on. Alright, now let's take a basic question which we'll solve using FPC. Alright, so let's take for example a password has two letters and one digit. Note for example, note this digit comes after the letters. So yeah, the format is fixed. You cannot put one letter then another number then again a letter. No, we have to put two letters and then one number. So yeah, but I'll for a better understanding, I'll write it followed by a number. So no confusion. Alright, so these are the conditions. Now let's see how many ways we can perform this. For letters, there are, let's take the number of letters available. So there are 26 ways, 26 choices of letters we can select. And for numbers, it's a single digit. Then we have options of from 9 to so from 0 to 9. Those are 10 choices. Alright, now if we try to form the password, so for password we'll take 3 blank spaces. For better understanding, I'll explain why we took 3 blank spaces. Now for example, this is our password. What, there's no number, no digits. We'll put options there. Now we have 2 letters to come here. Now for this place, I have 26 choices of letters. I can choose any letter from A to Z to put here. So we'll write, selecting a word for this place, we have 26 ways to select the word, and same goes for this place. Note, repetitions of letters are allowed. So if I choose B here, then I can choose B here also. So there are 26 ways I can select a letter to keep here, 26 ways to select a letter that I can keep here. Now for here we need a number, then there are 10 ways we can put a number here. Now we'll take for example, I selected A here, then I selected B here, and I selected 7 here. So this is a password. Now I can change and select B here, C here, and here 2. So this is one password. So yeah, we have 26 options for this place, 26 options for this place, and 10 options for this place. Now using FPC, I'll just move it a little bit upward. Alright. So now using FPC, we knows the number of ways to do something is m into n into p, m into n into p, because there are 3 digits here now, 3 options here now. So yeah, m into n into p. So it is basically 26 into 26 into 10. So these are the total number of passwords we can make by this conditions, from these conditions. So yeah, now what is this? Calculating this would give us 6760. So there are 6760 possibilities of making a password by these conditions. That's the real power of FPC. Multiply the number of choices, done. So if we had a different condition, let's take if we had one more option of digits, then I would have 10 more options, and I can choose any from those. Then here, calculating the total possibilities, we just need to multiply it again by 10. So yeah, the possibilities would change from 6760 to 67,600. It's this simple. That's it. Now there's a method known as tree diagram to visualize how and why we actually multiply m into n, the number of ways to do an independent task, with the number of ways to do another independent task. Why do we do that? So for that, let's take an example and draw a tree diagram for it for better visualization. Now we have to flip a coin. So a coin has heads and tails, followed by rolling a dice. A dice has 1 to 6 numbers. Now first we have flipped a coin. So by flipping a coin, we have two options and two possibilities. What are the possibilities? That either we can get a heads or we can get a tails. Now let's take for example, we got heads, then followed by the coin flip, there's the rolling of dice. Now we got head and we roll the dice. So for example, we got 1. So this is how it moves on. This is one win possibility. For other possibility, we can take, we got head and 2, 3, 4, 5 and 6. Same goes for tails. So after heads, we have 6 possibilities of 1, 2, 3, 4, 5, 6. And after tails, we have 6 possibilities 1, 2, 3, 4, 5, 6. Now we see that we had 2 branches for coin flip, heads and tails, and after that we have total 1 2 3 4 5 6 1 2 3 4 5 6 12 total 12 number of outcomes which can be possible, and each one is different. Like if we take heads and then 6, which would be different from heads and then 5, so each one is a different possibility, and there are total different outcomes which are 12. Now we did the same thing by multiplying. We just multiplied number of ways possible for a coin flip, which is 2, multiplied number of possible outcomes for a rolling of dice, which is 6. That also gives us 12. So yeah, this tells us why we multiply independent number of ways of doing an independent task with another independent task. So tree diagrams visually show why we multiply. Alright, moving on. Our next topic is factorials. This is a very important thing in PNC. Factorials simply means multiplying number from n down to 1. Now what does that mean? There's a formula for factorial, which is n into n minus 1 until it reaches 1. This is the formula, and the notation for factorial is this exclamation mark with the number n, where n can be any whole number from 0 to any number. We can basically write this into n minus 1 factorial, or basically n factorial, which is same. So yeah, this is about factorials. Now let's take an example. What is factorials? Now if we talk about 5 factorial, what is 5 factorial? So basically 5 factorial is 5 multiplied by 4 and multiplied by n minus 1 till it reaches 1. So this would be by 3, by 2 and then 1. So this is 5 factorial, and solving this we get 120. Same goes for 4 factorial, which is 4 into 3 into 2 into 1, which would be 24. Now if we notice, we can write it like this in this format by simply, now 5 into 4 into 3 into 2 into 1. This part here is basically 4 factorial, because we can see here. So we can write 5 factorials also as 5 into 4 factorial, and same goes for other numbers. Also, there's one important thing I need to say, which is what is the factorial of 0. Now remember when I said n could be a whole number, so a whole number consists of 0 too. So what is the factorial of 0? There is no number preceding 0, but the answer for this is 1. Yes, that's a real definition. It's not defined, it's not infinity, it's nothing, it's simply 1. Factorial of 0 is 1. Now we'll see this later in our video or in future videos. We'll not talk about this right now. So let's move on with another topic. Now let's understand why factorials are so important. So imagine you have 5 different books and you want to arrange them in a row. So what we have, number of books we have are 5. Alright. We need to arrange them in a row. Now how many ways can you do it? So we'll solve it by the same method we did for finding the password, finding the number of ways to form a password. So yeah, so 5 books, we have to arrange them in a row. So the number of single places available in a row are 5, because total books are present are 5. Alright, these are 5 places in where each one of the book will be placed. Alright, now let's see for the first place. Now we have 5 books. For the first place we can put any of these 5 books. So the possible ways to so the possible way for this is we have 5 choices. So there are 5 ways to fill this place. Then moving on, now we have already kept a book here. So we don't have 5 books anymore. Now we are left with 4 books. So to fill this place, now we only have 4 options. And then moving on, for this place we only have 3 options, and then here only 2, and here only 1. Because unlike passwords, we cannot repeat books here. We cannot place one book at 2 places at the same time, right? So yeah, the choices reduces as we start placing books. So example here, I have already kept 3 books here. Then what are we left with? 2 books. So I can only place 2 books in this place, and once I place 1 book in this place, then I'm only left with 1 book and only one choice to place. Alright. So now what is this? Total arrangements. So now for total, we know that we need to multiply the total possible outcomes, independent outcomes. Now for the answer, we know that this can be written as 5 factorial. So we know 5 factorial is 120. So this is the use of factorials. Now this is basically the first idea of permutation, even though we are not using the formula yet. Yes, this is the basic form of permutation. We'll talk about permutation and the difference in from permutation and combination, but not right now. Just know that this is a basic example of permutation. Alright guys, here's a basic question. So let's solve this question. Now the question says, how many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5 without repetition? So yes, let's use the same method, that for 3-digit numbers we have 3 places to be filled with numbers, right? Now let's take how many ways a place can be filled. So for the first place we have 5 options, because we can choose any number from these 5. Now for the second place, the question says without repetition. So the number formed cannot have same digits. For example, 3, 3, 3. This is not allowed. But 3, 2, 1, this is allowed. Alright. So now repetition is not allowed. So for example, I have filled 4 here from these. Now we can cancel this out because we cannot repeat. So what we are left with are 4 options to be filled in the second place. So these are 4 options, and same for here. Now we have put 2 numbers, like example 3 here. Then I am only left with 3 options here. So total possible ways is 3. And let's say I put 1 here. So this is one combination of number, and this is the total ways. If we multiply, this is the total ways to form a 3-digit number. So what is our total answer? The total answer is 5 into 4 into 3, which is equal to 60. So we have 60 possible ways to form a 3-digit number using these 5 digits without repeating a single number. Alright. So notice how repetition changes the entire logic. We'll explore that deeper in the next video. Now, what difference did repetition make? Now if we remove the repetition part and then form the numbers, then we can have 5 options here, 5 options here, and 5 options here. Now multiplying this would give us 125, which this 125 outcomes includes number like this, where either 2 digits are repeated or 1 digit is repeated 3 times. Now this 125 contains numbers with a digit repeated twice or a digit repeated thrice. So notice what a difference repetition and not repetition makes in our question. So while solving questions, please note that if a question says the digits can be repeated or not, because this changes our answer by a lot. Alright guys, so that is it for today. Now let's talk about the summary before we end our video. Yeah, I've said that we would talk about summary before solving questions, but yeah, the question wasn't that hard. So yeah, we just solved the question before. Now we'll, before ending the video, we'll talk about the summary. So what we've learned in this video is the backbone of PNC, which is multiplying choices. M into N, or also known as fundamental principle of counting. M into N is equal to total ways. Then we have learned what independent events mean. The same example of shirts and pants can be used. Then we talked about tree diagrams for better visualization of how and why we multiply numbers, why we multiply the number of ways. Then we have talked about factorials. Remember that I still need to explain why 0 factorial is equal to 1, which we'll talk about in our next video. So yeah, this is the topic remaining from factorials, but yeah, I've talked about factorials. And then we have seen basic permutation. Yeah, the arranging the books in rows example was an example of permutation. So if this is clear, the rest of PNC will be smooth, because these are the basics we need to learn before solving PNC. So if our basics are strong, then the future topics would be a little easier to understand. So yeah, that is it for today, guys. So if you liked our video, please like, subscribe and share this video. And if you have any suggestions for us, then you can comment it down. Thank you for watching.